Hello and welcome back. I am Sam, your lead tutor. Today, we are going to answer the question every user asks, why is the network slow? We are tackling K64. This knowledge point covers the main factors that affect network performance, like latency, jitter, and packet loss, and how to fix them using tools like quality of service or QoS. Think of a network like a highway. If everyone drives at once, you get a traffic jam. An ambulance carrying a critical patient gets stuck behind a truck carrying gravel. As a network engineer, you cannot just build more lanes. You have to become the traffic controller. You need to set the rules so the ambulance always goes first. Our goal today is to give you the tools to do exactly that. Let's use my scaffold and ascend method. Before we can fix performance, we must identify what kills it. We call these the performance killers. First, bandwidth. This is often confused with speed, but it is actually capacity. It is how wide the pipe is. Second, latency. This is the time it takes for a packet to travel from A to B. High latency makes everything feel sluggish. Third, jitter. This is the variation in latency. If one packet takes 10 milliseconds and the next takes 100 milliseconds, that is high jitter. It ruins voice calls. Fourth, packet loss. This is when data simply disappears. The network has to resend it, which causes massive delays. So, how do we fight these villains? We use quality of service, or QoS. The core principle of QoS is managed unfairness. We deliberately treat some traffic better than others because not all traffic is equal. A voice call must happen in real time, an email can wait a few seconds. We do this in 3 steps. First, classification. We tag the packets so the network knows what they are. Second, queuing. We put the important packets, like voice, into a priority queue, the fast lane, so they leave the router first. Third, shaping and policing. We actively slow down or drop less important traffic, like YouTube, to ensure it doesn't hog the bandwidth. Let's look at the specific tools. First, traffic shaping and policing. Traffic shaping is the gentle approach. It smooths out bursts of traffic. If a user tries to send too much data, the router holds it in a buffer and sends it a moment later. It delays, but doesn't destroy. Traffic policing is the harsh approach. It enforces a strict speed limit. If a user exceeds the limit, the router simply drops the extra packets. You use shaping for critical apps that are just being too bursty, and policing to punish bad behavior, like someone downloading movies on the guest Wi-Fi. Next is queuing. This decides the order in which packets leave the router. The default is first in, first out, FIFO. It's fair, but terrible for performance. If a huge file download gets in line before a voice packet, the voice call will stutter. We use low latency queuing, LLQ. This creates a VIP lane. No matter how long the other line is, voice packets jump straight to the front. To do this effectively, we need deep packet inspection, DPI. This allows the router to look inside the packet and say, this is Netflix, put it in the slow lane, or this is Zoom, put it in the fast lane. Let's apply this. The CEO complains that her video calls freeze every afternoon at 2 p.m. First, you diagnose. You look at your traffic analysis tools. You see that at 2 p.m., the marketing team starts a massive cloud backup. This fills the pipe, causing jitter and packet loss for the video call. You implement a QoS policy. Step 1. Classify video traffic as high priority. Step 2. Apply a traffic shaping policy to the backup server, limiting it to 10 megabits per second during office hours. The result? The backup takes longer, but the CEO's video call is perfect. You prioritize the business need over the raw data transfer. Performance isn't just about tweaking settings, it starts with design. Physical topology matters. Adding redundant links, like in a mesh topology, provides alternate paths if one link gets congested. Logical topology is even more important. We use VLANs to segregate traffic. We put all the phones on a voice VLAN and all the PCs on a data VLAN. This separates the traffic streams physically and logically, reducing noise, broadcast storms, and making it much easier to apply QoS rules later. Always design for performance first. Portfolio. K64 is powerful evidence of your troubleshooting skills. Use the STAR method. Situation. Users reported that the main inventory application was slow during lunch hours. Task. I needed to find the cause and restore performance. Action. I used deep packet inspection, DPI, to analyze the traffic. I discovered that staff were streaming high-definition video during lunch, saturating the link. I configured a traffic policing policy on the firewall to strictly limit video streaming traffic to 5% of the total bandwidth. Result: the inventory application performance returned to normal immediately. Reflection: I learned that you cannot fix what you cannot see. Visibility is the first step to control. If you are doing your major project, K64 is essential. You need a performance strategy section. Start with a baseline. Show graphs of the network performance before you made changes. Then, detail your strategy. Write, I implemented a 4-class queuing model to prioritize voice, critical data, and management traffic over scavenger traffic. Include the actual configuration code, your class maps and policy maps. This proves you didn't just talk about performance, you engineered it. To conclude, remember that a fast network isn't just about buying the biggest cables. It is about setting smart rules. Your job is to identify the killers, latency, jitter, packet loss, and apply the fixes using the QoS toolkit. You are the conductor of the orchestra. You decide who plays loud and who plays soft to ensure the overall harmony of the network. I challenge you to log into a router today, even your home one, and look for the QoS settings. See if you can prioritize your own gaming or video traffic. Thank you for your focus, and I will see you in the next session. Thank you so much for joining me today. I hope you now feel more confident in mastering this topic. If you found value in this session, I have a small favor to ask. Please hit that subscribe button, give this video a like, and follow our channel. It really means a lot to me and helps the algorithm show these lessons to other apprentices, just like you, who need support. Don't forget, you can download today's slides and the full transcript at www.mentorinai.com EPA Hub. While you are there, check out our mock interview and portfolio review services to make sure you are fully ready for your EPA. See you in the next video. Keep learning.